Here in this diagram, he given question related to stopping potential and frequencies. So on y-axis, photo current, on x-axis, anode potential. As potential increases, actually electrons come out of the plate. So as potential increases, so current is increasing. After a certain stage, even though potential is increased, there is no increase in the current, that is saturated current. Here, how intensity depend upon current, photocurrent. Intensity means more number of photons are incident on metal surface. So more electrons will come out. So obviously more electrons are coming out. Photocurrent obviously increases. That means intensity which implies photocurrent is proportional to intensity, keeping frequency fixed. Now here, so intensity of C, intensity of B, intensity of A. From this diagram, obviously, intensity of C is more than intensity of B is more than intensity of A. So, which clearly indicates, so that is related with the first option. But here, obviously we are in a position to decide answer, but how stopping potential and frequency are interrelated. So we know energy of a photon is h nu. It is frequency. As frequency increases, incident energy increases. Once incident energy increases, so proportionally electron come out faster. That means its kinetic energy is more as intense as Frequency is increased, photon energy is increased, electron comes out with more kinetic energy. So to here stopping potential, definition, potential required to stop any ejected electron. So with more speed electron is coming out, more potential has to be applied to stop the electron. So as frequency increases, stopping potential increases. If at all stopping potential same, so frequency must be same. So stopping potential is same, frequency must be same. So suitable option is first one. Here, only thing is he given PV graph, suitable PT graph he is asking. Let us come to different paths. In C2B, here in C2B, if you observe here carefully, pressure is constant. So when pressure constant, how pressure and temperature are related? Here pressure constant, NR constant. So volume will be proportional to temperature. As temperature increases, volume increases. Right. Keeping pressure constant here in C dash to B dash, keeping pressure constant. So actually we have to so here PV graph is given, right? We have to draw PT graph. Yes. In CB graph, volume is increasing. In C2B, volume increases, keeping pressure constant. So volume increase, P constant, NR constant. When volume increases, temperature also increases. So this C dash B dash says from here to here, pressure is constant, temperature, because here in this case volume increases V to 2V, the temperature increases. If I take C to A here, keeping volume constant, so PV is volume is constant, NR constant, pressure is proportional to temperature. That means P is K. It's like Y equal to Kx, which represents a straight line through origin. So C dash A dash is suitable graph in option 1. And another point, if you consider A to B, volume increases, pressure decreases, that is PV becomes constant. That is possible. That is temperature constant, which is another name, isothermal process. So now, so from this, in A to B, volume increases, temperature constant. So I want to establish a relation between P and T. So temperature is constant, nRT. PV becomes, we want to establish relation between P and T. P here is nR by V into T. So at constant temperature, volume increases. At constant temperature, volume increases, pressure decreases. If you observe this graph at constant temperature, in this graph, you know that volume is increasing from A to B. So pressure must decrease. Increases, A dash to D dash, pressure decreases. So suitable option is first option. So here, pendulum of same amplitude but time period is given from two opposite extreme positions. One is started from here, other is started from here. So here about executing SHM, particle is at mean position. We will take reference circle Initially, point particle is not at M. Initially at N, let us say, at time 0, particle is at N, not at mean position, then so it has an initial phase. So sine phi is equal to this Mn by amplitude. So that Mn here is A sine phi. A sine phi. When it particle starts from mean position, we have to use this. Initially, when particle is at extreme position, it has an initial phase pi by 2. Then after a certain interval of time, it makes an angular displacement. If it starts from right extreme x, then the equation which we have to write, because initial phase is pi by 2, that is A cos omega t. Right. So this one, for this we can write, he told same amplitude, but time period is different. Once time period different, angular frequency different. Whereas once it starts from here, this angle is 270 degrees. So say y, if it starts from y, then x will be A cos 270 plus omega t. Right, sorry, A sin 270 plus omega t. That is which is nothing but A cos omega t. Or you can write A cos pi plus omega with different time period, different time. Now, these are phase angles. These phase angles difference is either 0 or 2 pi or 4 pi, they are in the same phase. So what I am doing is I will take omega 2t minus omega, okay, omega 1t minus, if I take first case least, so when n is 0, then we have they may meet first time, second time, like that. N0 they meet first time. That is the minimum time in which they are in the same phase. So 2 pi by t1 minus 2 pi by t2. T2 minus T1 by T1, T2. So, which is T1, T2 by 2 times T2 minus T1. One is 7 seconds, other is 3. 2 into 7 minus 3. That is 21 by 8 seconds, after which they are in the same phase. So here vernier scale is right of main scale, then positive error. So how they design vernier scale, as usual, main scale so one unit they divide into 10 divisions, but vernier scale here he defined as 20 divisions for one unit. So what they mean to say, 10 divisions of main scale coincide with 20 divisions of vernier scale. One vernier scale division is 1 by 20th times main scale division. So smallest division he given 1 mm. That is how much? 0.05. Sorry. 10 divisions of main scale coincide with 20 divisions, half mm. So that is 0.5 mm. So here he says vernier scale lies and 15th division of vernier scale. So that zero error, how much it is to know it? It is vernier scale is coinciding with 15th division. For one division, 0.5 mm. For 15 divisions, 15 into 0.5, that is, there it is 10 by 20 half main scale, that is 0.5 mm. It is a small mistake I made. So one main scale division is this, it is 0.05 mm. So that is 0.05 mm. Because he defined here one main scale, smallest division is 1 mm, right? Now answer is error is positive and its value is 0.75 mm. If a source of 4 kilowatt produces 10 power 20 photons per second. So to decide the radiation belongs to which region, we have to find either wavelength or frequency. So here intensity is equal to, or we given power, right? Power here is NhC by lambda. N is number of photons. Hc by lambda is energy of a photon, total energy by time. This he given 4 into 10 cube kilowatts. So N here is 10 power 20 per second. Time I will take. Hc value, we know that 1240 electron volt nanometer by 10. 1 electron volt joules. 1 nanometer 10 power 9 meters. So here time I will take 1 second because he given per second. Lambda I will write. So 1240 into 1.6, 10 power 20, 10 into 10 power minus 9 by 4 into 10 cube is lambda. So here it is 0.4. 124 into 1240 into 0.4. 596 into 10 power minus 11 meters. This region is belongs to X-rays. Here it is a concave mirror. So diagram. So like this. Here question is, object is placed at O at a distance 20 centimeters. Focal length is 10 centimeters. So for lenses, 1 by f is 1 by focal length of a convex lens positive. U here is minus 20. 1 by V will be 1 by 10 minus 1 by 20. That means image is formed here at 20 centimeters. Or you can say, if object is placed at 2 times focal, 2f distance, image also formed at 2f distance. Without simplifying all this, we can say. Now this image becomes a object for a concave mirror. Now here, once this is an object, with respect to mirror, somewhere image will be formed. That image works as an object for a lens, and that image, its image with respect to lens must be here. Right. So here many variables will come, but only one simple concept help us to answer easily. There are two possible answers. So in case of mirror, object is placed at the center of curvature of a mirror. Image will be formed at the same point. So that means, so here for this focal length is 60 centimeters. 60 means center of curvature will be at 120 centimeters. So this distance is it is 120 centimeters. So that 120 centimeter must be here. This must be the center of curvature 120. So then object is placed here at 2f distance. Again image will be formed at 2f. I hope you understood. It must be the center of curvature. So center of curvature will be at a distance 2 times focal length, 120 centimeters. So if object is at the 2f distance with respect to lens, image will be formed at the 2f distance. That means distance between mirror and lens will be 20 plus 120, 140 centimeters. So other possibility is so this is lens. Here you have a mirror, right? Concave mirror. Here is an object at 2f distance. Once rays incident at the pole, it gets reflected. Again, those rays converge at 2f. This is possible when mirror is placed at. So that means at the where first image is formed, at that point, pole of a concave mirror is there. They get right. After that, they get reflected again at lens. They get reflected. So refracted, and finally, image will be formed at 2f. So in this case, distance between lens and mirror is only. So there are two possible answers for it. Either you write 140 or 20, both will be correct. So here, to solve this type of problems, we don't know. Generally, potential on the ground is 0. Let me write VA. So potential at A, let us apply Kirchhoff's law. So negative terminal to positive terminal 10 volts. And here potential across this. So I am choosing this path minus Q by 2C. Potential across this minus Q by C. So let us write here VB. But we know that potential on the ground is 0. That means 10 minus q by 2c minus q by c is 0. So q by 2c plus 10 equal to 3q by 2c. So q here is 20c by 3. C he given 6 microfarads is 40 microcoulombs. Here this type of calorimetry problems, one is hot body, that is when compared with the ice, 100 grams at water at 80 degrees, here 100 grams of ice at 0 degrees. When hot body and cold body are mixed, they get a equilibrium temperature, final temperature. Hot body loses heat, cold body gains it. This as a reference point I am taking. To convert 100 grams of ice at, it is 80 calorie per gram. So to convert 1 gram of ice at 0 to 1 gram of water at 0, we require how many calories? 80 calories. For 100 gram of ice, 100 into 80 calories, 8,000 calories are required. So when compared with reference level, hot body, so energy, heat energy with hot body is 100 specific heat of water, 1 ms delta T. Here is 0, delta T is 80. Exactly same amount of energy is available. So total ice melts and it converts ice at 0 to water at 0. And hot body, water loses heat and it also comes to 0 degrees centigrade. Answer is 0. Here a particle is projected at an angle 60 degrees with the horizontal with a speed 10 meter per second. After some time, direction of the velocity, which makes an angle 30 degrees with the horizontal. Speed of the particle at this instant. At any point in two-dimensional motion, it has one is horizontal velocity, which is constant throughout the path u cos theta. Vertical velocity Vy, initially it has u sine theta. After t seconds, it's like v equal to u plus at formula. Vertically velocity changes. Velocity will be resultant velocity. So now you know it. Angle, projected angle, you know it, cos 60 half. G, you know it. So 25, pi root 3 minus gt whole square. To calculate this velocity, I don't know t. For to find out t, some information is given. Here, tan 30 will be vertical velocity by horizontal velocity. 10 root 3 by 2, 60 degrees projected. 10 cos 60. 5 by root 3 is 5 root 3 minus gt. 15 minus 10, 5, 10 by. Now resultant velocity becomes gt value is 10 by root 3 whole square. 15 minus 10, it will be 25, 1 plus 1 by 3. So 25 into 4 root 100, which is 10 by root 3, which is k by root 3. K here is 10 meter per second. Here, the resistance is 3 ohms, reactance, the power factor. So power factor we calculate by is cos phi, which is R by Z. So here Z is impedance R square plus XL minus XC also. XL, you know, inductive reactance. XC, you know, capacitive reactance. He is not given inductive or capacitive, he given reactance means that is just resultant reactance he given, that is 4 ohms. Here Z will be 3 square plus 4 square. 3 by 5. This is power factor. 6. So here Wheatstone is bridge is balanced when P by Q is R best. This is a non-derivation. But here, in fact, directly bridge is not balanced. So something has to be connected to yes to balance the bridge. Here it is, this should reduce to equate. If you add it in series, that denominator will increase. So I am connecting the resistance parallel to 4 ohms, some X. So effective resistance will be 4x by 4 plus x. So that is 2 by 3 is 2 by 4x by 4 plus x. 12 plus 3x. That is 12 ohms must be connected parallel to S to balance the Wheatstone bridge. Here it is a rated voltage. With the help of this, we calculate resistance by using P square by P. 250 into 250 by 100,000 watts. So resistance is this much. Sorry, 250 by 1000 is 8, right? Hmm? Correct one. Right. This is resistance. It is connected to what 250 volts means, then current will be 250 by R 125 by 2. That is 4 ampere current. Potential difference across the terminals of a battery is 10 volts. That means VA minus VB is how much? Here EMF is E. Battery may have some internal resistance. When current 3 amperes flows from negative to positive terminal. That is, if I apply Kirchhoff law, VB here negative to positive means plus E minus IR in the direction of current um, moving from B to A, which is VA. So that is VB minus VA is minus E plus IR. So potential difference, he given it as 10 volts. When the current 2 amperes in the reverse direction, so reverse direction, here A, here B. So VA positive to negative minus E resistance independent of the direction, which is so potential difference will be E plus IR, which he given it as 15. So adding these two equations, 2E will be 25. Or subtracting minus 2IR, sorry, here I1 current, right? So 3 amperes, that is E minus 3R is 10. Here 2 amperes current, E plus 2R is 50. So subtracting one from other, we get minus 5R is, so internal here projected with a velocity 20 kilometer per hour. It is more than this. This is escape velocity. So definitely to enter into a interstellar space. So when at the time of projection, energy associated with this is potential energy, and the it is projected with some speed. So with that speed, it gains kinetic energy. At interstellar space, there is no potential energy. It has only kinetic energy with some velocity. Escape velocity formula, we know it. So Gm by R will be V square by 2 minus V square by 2 R, so plus half mv naught square. So this is the velocity which it has in interstellar space. V naught square minus V square. 20 square minus, so 400 minus roughly 120. 11 square is 121. Let us take like this roughly 275. 15 square is 225. 16 square 256. It is in between 16 and 17 roughly. The rest of inclined plane, some letters are missing. Its coefficient of friction, tan theta is 4 pi. So it is allowed to slide down. So from an inclined plane, where it is mass having 2 kg, so coefficient of friction is 1 by 3. Kinetic energy acquired by that dropped body when it reaches bottom of the plane. So V square is because it's moving in a straight line. Initially, no velocity. Acceleration will be g sine theta minus mu g cos theta. That yes, he given one. Once it is an inclined plane, so because of its weight component, it is a normal reaction. This will be mg cos theta. Frictional force mg cos theta. Net force is the difference. From that you can calculate acceleration. G here is 10. Once tan theta is 4 by 3, sin theta will be 4 by 5, cos theta because. So V square is 12. Kinetic energy is what?